Hi everyone. Okay, so we are continuing in Module 1, Topic 2, Lesson 2, and now we are working on Activity 2, and this is on page 82. Area of complex figures. You can divide more complex figures with oddly figured regions into smaller familiar regions to calculate the approximate area. Habits of mind. Look for and make use of structure. Look for and express regularity and repeated reasoning. Number 1 says draw lines in the figure to divide the figure into smaller familiar figures, then name the familiar figures that make up the total figure. So right away, I kind of see a triangle if I go across here. So I see a triangle. Then I can see if I draw this down here, I can see, I guess it depends on the measurement. It could be a rectangle or a square. And then right here, I see a trapezoid. Okay, I want to look at 2B. 2B is the one that I want to look at. So we have this very odd shape, and we need to figure out its area. Right away, I see like a triangle sticking out here, and a triangle here. But then I also see, if I go across here, I see a parallelogram at the top. So I think I can do the area of these 4 different shapes and then kind of add them all together. So as I look at this parallelogram right here at the top, I'm going to use a few different colors here. As I use that yellow to show the parallelogram, I know that it has a measurement of 3 here, which means this side is 3. Then off here to the side, I see this 4. That is showing me the distance from here to the top. So it's got a height then of 4. So I'm going to call this maybe shape A here, so I can just kind of keep track of the work that I'm doing. So I'm going to come down here and write A, and the area of a parallelogram is base times height. Sorry, that's my kitty Lily that you hear. She wants all kinds of attention right now. So the base of this parallelogram is 3 with a height of 4. So the area of that is 12 centimeters squared. So our letter A is 12 centimeters squared. Let's call this rectangle here B. And let me just kind of highlight that in a different color. And feel free to use different colors, whether it's crayons or colored pencils or highlighters, or maybe you just have different colored pens, or whatever you have is fine. So B is the orange. Well, I noticed that the yellow in the parallelogram here on the bottom matches up with the top of the orange here, so that must also be 3. Those are exactly the same line, part of this shape and part of this one. Ouch! Oh, she just stuck her claws in me. Okay, so for shape B, which is a rectangle, we have area equals length times width. So that's the area of my rectangle. This was a parallelogram. Okay, so my length is 9, so area equals 9 times, and my width is 3, which gives me a total area of that orange rectangle of 27 centimeters squared. Okay, let's look here at this triangle. We'll call that a C. We know area of the triangle is half of the base times height. So that triangle is here. So which one's the base, which one's the height? Now it's kind of on its side, so to speak. If I flipped it this way, then I'm guessing you would view this line right here as the base pretty easily. And that really is where the base is. And if we look at that distance, we have these kind of measuring lines here off on the side that is showing us that from here, the corner of that triangle, to the corner right here has a distance of 5. So our base is 5. So notice I'm rewriting my equation each time. Area equals half of 5. And then the height, remember the height is the distance from the base to the highest point on the triangle, which is here. So right here is my height. So what is that distance? Well, you have to really be a detective here when you're doing these composite figures. I know this is 3, so this part down here in this rectangle is 3. And then I'm told right here that the distance from all the way here on the left all the way across is 6. If I know it's 3 from here to here, then this distance here must be 3. And that is the same distance as the height as this dotted line I drew here in triangle C. So our height is then 3. So we have area is half of 15. So our area of triangle C is 7.5 centimeters squared. Well, then what about triangle D? Again, it is a triangle. Area equals half of the base times the height. So triangle D, which I guess I should put a D there. It's like right here. So the base kind of hops right out at us there, and we just talked about that here a second ago. So the base is 3, and then the height is perpendicular to the base and touches the triangle at the highest point. So this side right here is the height. Well, I'm given this distance of 4 here on the side. Does that line up? It does. So our height here is 4. So then we have half of 3 times 4. So that's half of 12. So we have an area of 6 centimeters squared. So then to get all of the entire shape, we just need to add each of these individual A, B, C, and D areas. So let me do that kind of up here. So A was 12, B was 27, C was 7 and 5/10, and D was 6. And I can put decimal points and zeros there if I want. Make that easier. Decimal stays lined up when adding and subtracting. So here we have 14, 16, and 6 is 22. 22, and then I write a 6. I'm okay. 22 and carry a 2. 2 plus 1 is 3 plus 2 is 5. So 52.5 centimeters squared is the final answer. Okay, and I think that's all that I wanted to do there on page 82.